Hi, my name's Andrew McLaren, and I want to help you with limiting reactant problems. I've worked as a tutor with a ton of students, and getting this big picture kind of roadmap or some sort of visual is usually what students need when they're struggling on these problems. So I'll usually use this butterfly map, and I'll tend to use this method one, but there are multiple methods to work between what you initially had, what you've used, and what you still have left over. But essentially, you're going to need to do some sort of conversion from like used to produced, which is going to be related through moles. So that's why there's this butterfly. It goes through the center here. So if they're giving you grams, you got to turn that into moles to then relate that to like a product or a different reactant. So all this stuff is related through that reaction, those quotients. Um, but we also need to do some conversions. But then in addition to that, you're going to need to think about like the initial moment, the change, and the final, and how those three compare. So option one is basically you compare how much product could be formed from the two. Whichever forms less is going to be the limiting reactant, but then there's a difference between those products, and that's how much product could still be formed from the excess. So that you can then correspond and relate back to the moles or grams of the excess. So what this ends up looking like is something kind of like this. Now I've tried to color coordinate a little bit. So like here I gave a path of going from grams to moles to moles to grams. And it looks like I had two tracks. So it looks like I had this blue track and this red track, considering those two different reactants, looking at how much product they could form. So there is a limiting reactant that we can see right here, and it's running out first. So that's obviously using up all of that, so it can't produce any more of the from the limiting reactant, but the other one has some excess amount that it could still be produced from. So you've got about 84 grams here that could be produced. We got about 71 grams that was produced, so you've got about 13 grams that could still be produced. So then you could say, like, let's imagine that you are producing 13.1 grams. How much of this reactant would correspond to that? So you end up using conversion ratios, grams to moles to grams, a lot of the times in these problems, because most teachers are going to have you in the butterfly just going along this path right here. And you're going to have to do that for like two different masses, which will have two different mole ratios. So that's kind of like the most common track in the butterfly. And then there's something kind of neat that you can do with called the percent trick, where you can look at how much percentage has been used, and that should be the percent of what it could form as well. So it looks like about 90% of this stuff was used, so about 10% was left over. And that percent can kind of help guide you to see if your answer is reasonable or not on these problems, because there's a lot of steps, right? And you could make a mistake, so you want to be able to double check your work. So the second method is if you can find out how much one reactant will react with the other reactant, then you can figure out from that which one runs out first, because it's going to react with less than what's available of the other thing. So you can do that, identify which one's the limiting reactant, just going from reactant to reactant, and then using that, you can just, knowing which one's the limiting reactant, solve for how much product is formed. And you can also, therefore, also find the excess as well. So it's a bit weird for me doing it this way, because I usually do option one. But you can see for this problem, they've given you moles. So you're just going from moles to moles. So if you're looking at your butterfly here, we're just going from here to there, but we're doing so with like two different possible reactants and comparing which one runs out first. So if we look here, it looks like if we say R1 is reacting with R2, we've got this amount of R1, and it is going to react with about 1.65 moles of aluminum. Now we had more than that, so we've used up some of the aluminum. We could do the other conversion, but just from this, I can tell that I have used up some of the aluminum. I haven't used up more than what's present, so I don't have to do the other conversion. So here we have how much this will react with. And that's what was used. So we had the 3.2, we've used to the 1.65, so the excess amount is 1.75. Yeah, I've got some notes on how change and final initial work. You can think about this as a change and final initial. But to reinforce this is like option 1. If you were to try and do the math, you would do the 2 tracks, compare the numbers, and then this is what was actually formed. We could still form that amount, so this could still be formed, and that corresponds to the amount that's excess. So we are getting the same amount of excess from option 1 and option 2. Option 2 might look a little bit more direct, but you have to identify which one's the limiting reactant first. So that's essentially what we're doing here. Just you're doing it a little bit more in your head. And in this problem, it looks about half of the stuff has been reacted from the one that is in excess. 100% of the limiting reactant has been used, but about 40% of the excess reactant was used, leaving us with about half of what we had originally. Sorry, it looks like this is actually about 60% that was used. So we're being left with about 40%. It's about half and half, but you can see that we have a bit more used and a little bit less left over. So yeah, close, but not quite right. So this is a method that I don't use so much, but if you want to, you can take the 2 amounts of product that could be formed, identify which one's smaller, and then just convert that to the amount of reactant that was used. Then you can do a change or final initial calculation to find the excess, considering that we've taken that away from the initial amount to relate that to the excess. So if you were trying to do this, this isn't really typically how I do the problems, but this is the same problem as what I just did for option 2. But here we're looking at the 2 amounts formed. It looks like that 2.48 was what was actually produced. So that corresponds to what was actually used. So that's the change here. We had the 3.2. We've used about the 1.65, so we have an excess of 1.57. So you can solve this at least 3 ways. There's probably others. But as you can see, they all involve some sort of conversion going from like one chemical to a different chemical. And then they also involve some sort of change where there's an initial, final, and some sort of change. So those 2 processes will appear in no matter what options you're looking at. But if you have a roadmap and some color coding, it can really help you out in terms of knowing what you're looking at. I do have a whole separate video where I explain this a little bit more in depth, and I go over how I identify formed and excess and label all these different things. So if you want a more in-depth video that's a little bit longer, that should play next. I'll try and put this in a playlist for you. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there. And we can schedule hourly appointments. And I've got a few other things on here like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.